Hello everyone. We're having some kind of technical problem. I hope everybody can see me and hear me. I don't know what's going on, but looks like every 2 to 5 minutes transmission gets cut off on the internet. I lose contact with the server, and only on this computer, so I have no idea what's going on. We try to figure it out. We still haven't been able to. But if we get cut off, I'm just going to reset and continue. So just be aware that there could be some interruptions, okay? Anyways, we were dealing with a couple issues: philosophy, irrationality, and quantum mechanics. And they kind of all go together. they're all related. It's like you can't separate one from the other. The issue with philosophy is that we have no definitions today, no formal definition of what philosophy is. And the main reason for that is that philosophy is defined in terms of knowledge, truth, and who knows what else. And when you look up the word knowledge, it's undefined. It's still undefined to this day after 2,000 years. The most popular definition, you could say the scientific definition, I don't know if that's a valid way of putting it, is Plato's definition, justified true belief. In other words, knowledge is a belief, which is pretty much right, in my opinion, because there is no such thing as knowledge. Knowledge I define as the ability to run an experiment and predict the results of an experiment without a shadow of doubt. And you can't do that. You can't predict the future without a shadow of a doubt. At least that's my point, my position. So my point here is that the word knowledge has no bearing whatsoever on science, even though the word science comes from cere, which is the Latin, 2,000 years ago, the Latin version of knowledge. Science has nothing to do with knowledge. And assuming we could even define knowledge, right? But the point here is that science is about explanations and not about knowledge. And explanations have to do with the past. You can only explain a consummated event. On the other hand, knowledge has to do with the future. And the best example I can give you for that is, you know, in ordinary speech we say, oh, I know that Julius Caesar went to England with his troops. Well, what do you mean you know? Someone told you and you believed it and you memorized it for the test, whatever. But you can't run an experiment. You can't reproduce the observation again to prove to me or to prove to yourself or prove to the world that your knowledge is correct. No, you can't reproduce a consummated event.
But it goes back to the objective-subjective thing we talked about yesterday, where it could be objective knowledge in the sense that this is one of the things that could have happened. It's not that I'm saying I know that this is the one that happened. It's I know this is a possibility.
Yeah. And again,
wouldn't that be a version of knowing?
Well, again, knowing is, what do we say belief was? Belief is religion, right? And opinion is religion. What are we saying here? We're saying that out of the possibilities, which Hans came up with yesterday, which I thought was pretty good, objective versus subjective. Subjective means you're going to choose one.
Let's start with objective.
Okay, objective means you've got all these possibilities, okay? And that's quite objective. And you could propose one more, which is what I'm doing, for example, with a rope model. I'm saying, look, you guys missed one. Here, let me put that one in there. And that's also objective because I'm not trying to convince you. I'm just saying you forgot what we're brainstorming. We're still brainstorming.
Basically,
right?
The verb for objective for the objective part is brainstorming, while the verb for subjective is choosing.
Right. And so what we're doing when we're going into religion, when we're going into opinion, when we're going into belief, knowledge, which is justified true belief, is we're saying, I'm going to choose this one.
But maybe it's
truth,
not.
Truth, same thing for truth.
But that's my point. Maybe it's not, because maybe knowledge, as opposed to belief, could be the brainstorming part, where you're just brainstorming all the assumptions and combinations of assumptions to get to the bottom of something, like trying to explain magnets, right?
Okay.
Knowledge would basically be, in that case, at least it could be in this case, what are all the ways to explain magnetism? That's knowledge.
Yeah, but
the objective belief, basically.
Yeah, but again, then we would have to find out what the definition of the word knowledge is. And if we define the word knowledge in terms of the word belief, then we're back to religion. You know, knowledge has no place in science. And, well, anyways, those are questions of definitions of how we use these words in science and whether they belong to religion. And I'm saying knowledge belongs to religion, has nothing at all to do with science.
Yeah, I would say that knowledge belongs to science because it's the brainstorming part it's the objective part.
But then you would have to define the word.
Yeah, it would basically be, I guess I'd have to think about the exact wording, but everyone
got to give them homework.
Everyone knows the notion where it's not the choosing part, that's the subjective, that's the belief.
Right.
Well, knowledge is all the possibilities of any given question or any given situation.
But you know, the word knowledge is not used in that way even under ordinary speech. Right. When people say "I know," they're concentrating on they're already picking one. It's the belief, the belief version, not the brainstorming.
But when you're
version.
talking about general knowledge, like what is the human knowledge? Because that's also a way it's used in philosophy often.
Okay.
Where people say, okay, what do we know? What does humanity know?
Yeah.
Then they're more talking about all the possibilities of any given question, or let's say.
But then what you do in those cases is you're not dealing with one specific subject. You're dealing like, oh, this is the body of knowledge.
No, because it could be it could be one specific subject where it's like, okay, what do we know about air, for example? Okay. Then you list out all the properties, basically brainstorming all the properties of air. You're not saying, I guess you are choosing because you're giving it the properties, right?
I don't think you can reconcile knowledge with brainstorming.
No, because it is brainstorming. Because you're not choosing, you're just brainstorming everything that it.
Yeah, but then it's the word knowledge fits awkwardly with that, you know. Anyways, the point that
what's the difference between brainstorming and believing and knowing?
Well, again, I
guess the question is, what do we do when we're brainstorming? Real specific.
You're just throwing things in there which could be things which are not under knowledge. For example, I can even brainstorm, for example, right, that one of the things that causes the orbit of the Earth are angels, that they move the Earth around. And you say, well, you know, should we include that in there? Well, yeah, it's part of the brainstorming process. Does that mean we know that there are angels? Do we know for sure that space is warped? Do we know for sure, you know, that there is negative momentum transfer in quantum mechanics, which is the way they kind of explain, you know, attraction? You know, it's not that we know. It's if you're just going to brainstorm and say, look, these are all the things I can think of, I don't think you can say that's knowledge. Knowledge is when you select one of those. Then it makes sense to use the word knowledge, at least in ordinary speech, and say, I know that angels push the Earth around the sun. Now you know. Now you no longer are brainstorming. You're not saying, you're not even comparing. You're just saying, I've already selected one.
What is the process of brainstorming? Because it doesn't have to have two or more people. It could just be by yourself.
Yeah.
What's your process of brainstorming?
Well, it's just coming up with ideas that trying to imagine all the situations possible, even outlandish ones, you know, things that have no chance whatsoever. You might even brainstorm those. But, you know, if you do like put angels for gravity and you say, well, you know, I don't believe and I don't think angels move, but I got included under the brainstorming list just to cover that base, then I don't know. I don't know you can call that knowledge.
No, I don't care about knowledge.
I'm
talking about brainstorming.
Okay.
For example, like a detective, when he sees a crime scene, when he brainstorms, he has to list out, objectively speaking, obviously, because he's not picking one yet. But he kind of is. That's my point. There's a tricky thing. It's everything that you can think of. So it's,
Mr. Watson.
It's as objective as
Sherlock Holmes would do that to Mr. Watson.
Yeah. But it's not objective, because objective would be Like purely objective would be all the possibilities. But what really happens in brainstorming is there's this human error that goes in because it's everything you can think of.
Yeah, but again, that's why I can't see how brainstorming would be related to knowledge. Brainstorming.
No, forget knowledge.
No,
I'm
no,
talking
okay.
about objectivity.
Yeah, okay. But I'm saying is again, we're trying to really deal with the word knowledge.
No. I changed the topic.
Okay.
Forget knowledge. I'm trying to figure out if brainstorming is actually objective, because it is objective the way we use objective, where you're just trying to figure out something, and you're not trying to
believe yet.
But
you're not choosing yet.
But it's kind of like a blend of both, because you can't put in. I mean, you could put in angels killed this person.
Why not?
But you
to
don't
cover that base.
But why don't you?
But you
for
do.
For example, a detective would rule out angels 100% of the time.
Yeah, but you ruled it out. You ruled it out after brainstorming.
No, they never even think of angels.
Well,
why don't they think that they themselves did it? They don't put that in the categories.
I think that's wrong not to brainstorm angels. I think you should brainstorm angels. Whether you believe in them or not is a secondary issue. But I think you have to brainstorm and say, I covered that base. It's just to cover the base.
But that's not possible, because you can't brainstorm all the possibilities.
Well, as many as come to your mind.
That's
obviously,
my point.
You never cover all the bases.
That's my point.
You don't.
You're already sifting while you're brainstorming. It's like you kind of just think within the realm of what you think it could be.
Well,
so that's why I'm talking about lack of imagination, because that's how it happens with theoretical physicists, where they never even pondered the rope hypothesis.
Let's put it more clearly. They never pondered torsion. I mean, you have longitudinal waves. In fact, that's in the real physics video of today. You have longitudinal waves. You have transverse waves. And if you look throughout the internet, you won't find analysis of torsion waves. It's like nobody even thought about that.
That's my point. It's like...
So they missed that one. That's a big one that they missed.
You can brainstorm but still miss something. So the objective part is like it's as objective as you can get. Everyone's got a limit to how objective they can get, because they just can't think. Like, forget about picking. They just can't think of more possibilities. Like a detective could see a crime scene and think of 9 possibilities, but it happens to be the 10th one.
Yeah. Right? But let me say something about that. At AMD, where I worked for many years, we had quality circles, and those quality circles, an idea I guess that began in Japan. Anyways, they implemented that at AMD, and it worked pretty good. We had all these groups, maybe I think they never exceeded 10 people, and you had operators, technicians, engineers, supervisor. Everybody was in there. You had a representative from different parts of the organization, of different segments. And what the quality circles did, they started out with brainstorming. That was the first step. And so, the engineer, he comes up and he proposes things from his angle. I've got a specter right. This is what I'm thinking about. This is what I know about the process. This is what I recommend. This is what I think should happen. This is what I think is happening. And then the operator said, well, I'm on the line. I got to work with this machine every day, and this is the problem I've got. Supervisor has a different focus. He says, I got to get production out. Time is money, and my manager's on top of me saying, get those things out, those wafers out, and get the product out. And so everybody's got a different interest, and that's part of the brainstorming process, because you do begin with brainstorming. You got a problem on the line, you say, how do we solve it? Okay, everybody comes with a different angle. This is the operator, this is the technician, this is the maintenance guy who's got to fix the machine.
Because they need a solution that covers all the bases.
Yeah, and so brainstorming should be more, for it to be really productive, it should be more than one person. It really helps. In fact, here with my son, you can see that, I don't always think of everything that I'm supposed to think about, and he comes up and he says, "Oh, how about this?" And he comes up with new stuff. Okay,
two heads are better than one.
Two heads are better than one. Three are better than two, and so on. And so
it's
brainstorming,
got diminishing returns.
yeah, to some degree it is. At some point you fight more than what you propose. But the point is that brainstorming is a good start. It's good to have brainstorming. That's good. But then and then you should put everything on the table, even angels. You should put angels on the table.
Did you bring up angels at the AMD? That's the question.
No, we didn't.
So you weren't doing science.
But sometimes we were a little facetious, and probably we were shooting the bull at some point in time, and no problem. Someone would propose something outlandish, something out of this world. We'd say, okay, let's put it on the board. We would put it on the board and immediately scratch it, saying, well, we covered that base, right?
But the brainstorming process, it's intricate because it's not completely clean in the sense that, yeah, you can brainstorm without bias, but there's implicit bias because your mind can only imagine so many things. For example, someone who's never heard of human flight, right?
Right.
That's one less bag in his bag. One
yeah, but he can bring in
tricks.
Birds. He might say, well, like you can get a pygmy from the jungles and say, look, this is flight. And you say, well, I've never seen a human fly. I don't know what an airplane is, but I've seen birds fly, And so he might propose something from birds that you never thought about because you don't observe birds.
But that's my point. Everyone's got their own take, their own. I don't want to call it subjective because it's still brainstorming. It's still looking for an answer without bias, but it's that weird, cultural bias or upbringing bias where it's like a person can only think of what they've been raised to think about.
Yeah.
Something like that.
But nothing wrong with that as long as, again, if you have several people with different backgrounds, then you get a good brainstorming session.
I guess that's the point. To overcome your educational biases or shortcomings, let's say, you kind of have to do it with more people because the more people, the more the merrier. The more of the pie that Mother Nature knows is covered.
Yeah.
If one person can only cover so much, but then another, you have two people. Okay, they live two different lives. They have two different educational backgrounds, so they have different answers. But education plays a big role in that because we have all these physicists who all had the same education, so they're all just keep cutting out the same piece of the pie, and they're not leaving the. And
that is a serious problem because
outside the box.
Because they're all brainwashed in the same way when they go to college. The assembly line, the conveyor belt in which they all sit. They're all processed in the same way, and
but that's my point.
That creates a certain uniformity across the board, which is very bad for science
and for brainstorming because they all brainstorm within the same box.
Yeah. So they don't think out of the box.
But I think that goes to what you said about angels, where you have to always consider angels.
Yeah.
Just because it's out of the box, you have to consider things out of the box that you kind of offhandedly. I mean, sometimes when we're debating in the kitchen, one of us will say just. Because we're trying to get to the bottom of something, and we'll say something outlandish just to go down that route.
Yeah, to cover that base, or to change, or to think out of the box for a second at least, even though it's unlikely.
The first instance, the first thing you think of is it's not this, but let's talk about it anyway.
Right.
Just in case.
Yeah, let's make sure we can reject that possibility.
That's the real brainstorming.
You take it on a tangent and you go all the way to the end of the cul-de-sac to make sure that you covered that angle.
If you think about it, that's the best form of brainstorming because we both kind of understand things that we both understand. We both we have these things down, and we both kind of are still unsure about some question, right?
Yeah.
But so we both have to go outside of what we both know. We kind of have to think outside the box. That's kind of the when you're trying to figure something out for yourself, by definition, you have to think outside the box because it's not in your box.
Yeah.
Whatever answer you're looking for, you don't have it yet.
Yeah. And that's the way it should work, and again, one of the things that you have to look at is that, when you get people together and they brainstorm, they do a much better job than just the one person, unless all of them came out of the same cookie cutter.
Yeah, it's that cookie cutter thing. It's that cookie cutter problem.
Yeah, and that's the issue with mathematics. Mathematics, all these people come out of college with the same cookie cutter, and that's where the problem is. That's anti-scientific. It's, completely non-scientific.
It's weird. School in general is kind of anti-scientific in that sense.
Yeah, they kind of channel you through a tunnel.
It's good and bad. It's good for philosophy. It's good for living, how to live, but it's bad for science because the kids aren't trying to come up with answers on their own. They're fed the answers to memorize, which is good because you just need what's the right answer to live the right way. I need to cook.
But that's I need that to pass the test.
No, not pass the test. Not pass the test. To live. But you need math, for example, like to do your bills or to bake a cake. To know ratios. So they give you this cookie cutter, formula, for example, how to calculate something, which you might need to do your taxes, for example, or something.
Yeah.
But it's not that. That's different than doing science because there you're just learning something by rote. You're learning a creed in that sense, the way I use the word. You're just learning a tool that you can use later on. While science would be more, let's ask a question, even if the teacher knows the answer, right? Science would be asking the question and just letting the students figure it out. That's the science part. But what do you call the teacher just giving people the answer?
Yeah, and again, unfortunately, much of school is just memorizing. Yeah. And I guess that's what you're referring to. Yeah. I mean, history, a lot of that is memorizing. And again, I include it under philosophy, but what do I include? Explanations. If you can explain, why this guy did this, why that king did that, then it's good. But if you just memorize dates and say there was a battle in such and such date, all you did was memorize. Can you say that 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 happened? No, you just memorize it for the test, and maybe you remember it for the rest of your life, for all I know. But again, it's not there that science vibrates. Science vibrates when you have to explain something, why, the cause or reason in this case.
It's interesting because many people have that same gripe. Like many TED Talks are about the failures of education, and they always, because to me, education or school is twofold. It has two purposes. One is to teach you tools by rote memorization that you'll need in life, like writing, talking. These things you don't have to think about. It's just learning. But the other one is the one that everyone has a gripe with, which is school is there to teach you how to learn. It's there to teach you how to teach yourself. Basically, it's there to teach you how to think. How to what do they call it? Critical thinking. It's a skill that it's supposed to teach you, but school kind of left that by the wayside and stuck to the rote, to the memorizing.
I can give you two examples which show the difference between what we do in schools today and how it's supposed to be.
Not supposed to be, but
well, how it's supposed to be in order for you to use your brain, which is essentially what we're asking people to do. To use their brains, and it's not easy for a lot of people. People would rather say, hey, just give me the answer and I'll memorize it and we're done. No, you got to think about it. And here's where it goes. Socrates, he would discuss with his students, Plato, Xenophon, and so on. He had all these people around him, and they would debate. A question would pop up, and they would argue over that. And then, the student, the younger people said, well, this is my intuition, this is what I think. And that's when Socrates used his experience and say, well, how about this? And they went into these dialogues and so on. And that's how they learned. And I thought that was a very good way of learning because they exchanged ideas. And the other example that I have is the Jews. The Jews, as I understand it, they sit one across from another on a table. And they look at a paragraph or a verse in the Bible, in the Old Testament, the part that deals with the Jewish history and so on, and they start debating over that, and they exchange ideas with just one-on-one. And there's another pair here, another pair over there. They're on a long table and they discuss across from each other, and they argue. Argue.
And even better to that, there's a crowd like smaller kids who don't really know how to argue. They're watching people argue, so they're kind of learning how to do it. Just as an observer.
And the issue here is that sometimes you got to play just devil's advocate. Well, what if?
Yeah.
You know, and that's good because then people have to think.
That's how I learn. That's how.
But if people just memorize what everybody already found out, what we know, we just memorize what we know. Well, then then all you're doing is just absorbing. What is that? Is that science? Is that learning?
Science,
is that education?
It is because, like I said, it's twofold. You have to learn how to write, how to do math.
Yeah,
those things you have to get under your belt.
I have no problem with that.
Basics of chemistry.
I'm talking about explanation.
But that's my point. There's two things to education. You have to learn the tools, and you have to learn how to think.
Yeah, and the thinking part is where people are failing because people are just accepting what the mathematicians are feeding them without understanding, a lot of the foundations for those reasonings, for the reasons for why they came up with this stuff, because a lot of that is high-level math, and they say, well, from here we extrapolated these ideas, and people say, well, I don't care about the math because I don't understand all that, it's too complicated for me. I'll just take the results, the conclusions, and I'll deal with that. And they memorize that, and they say, okay, black holes, dark matter, Big Bang, and they don't know how these things came into being.
Yeah,
and they just accept the final thing, and they say, well, the mathematician, he's got a PhD, he told me, and so I'm just going to accept it. And that's where the problem is.
But because it's, to know something is off, you have to delve into the subject. Because, let's say you want to learn how the human body works, right? You're not going to cut a person open and learn it that way. You learn things by rote. We've learned, or you learn it through secondhand. You learn everything that we already know, quote unquote.
Yeah.
So everyone kind of took that same cookie cutter approach to learning. There's things we know about chemistry or things that general humanity kind of acquired, whatever you want to call it. Like we know, I don't know, no, there's that word again, but sodium chloride, we can do certain things if you learn chemistry that you don't have to learn from the ground up. And they kind of took that same approach to physics, where it's like, okay, these guys went off on a tangent. They went off on, the chemistry people went down the chemistry tangent, so you just have to learn what they learned. The physics people went off on a physics tangent, just learn what they learned. So it's kind of like the same. They don't see anything wrong because, again, to know there's something wrong with chemistry, for example, you'd have to go down that chemistry path and see, oh, well, hold on, there's this is wrong, there's details in it that you become aware of if you learn it enough, or geology or paleontology the way you do it.
Yeah.
So it's like you can't really know something's BS until you
go deep in it.
Until you dive.
Well, but the Indians, American Indians, the Sioux, and so on, they would pass down, and not only them, but I guess this occurred throughout the planet. They used to pass down stories. They'd sit around the fire and they would tell stories of what their forefathers did. How did they learn it? Well, it was passed down from generation to generation. And so now here was the old man of the tribe, or the senior member, or maybe just a father with son or whatever. And he would tell them the same story that he was told. And he said, oh yeah, Big Bear, 10,000 years ago, he did this, and he was a great man and did this and this and that. And he would pass that on to his son, and now his son knows the same story, and they would pass it from word of mouth to mind. And now it was, the son grew, and he was father, and now he would pass it on to his son or to other kids and so on. And over time, I guess it got embellished a little. I got this story that's changed a little bit here and there, and over time.
Happens with telephone games.
Yeah, and I guess the forefathers became ever more like gods over time. This guy was just a normal human, and eventually, I guess he went to Mount Olympus and became like Zeus, because he started having superpowers after several generations. And you get this, and we have a little bit of that in what you just said. The chemists, they went down this road, and they discovered all this stuff, and now you teach it to a new generation. And instead of investigating, you say, well, salt, everybody knows. I'm not going to do salt again. These guys did salt. I'll just take whatever they found and well, what if they did not cover every base? What if they got something wrong? Then I'm just memorizing stuff that I shouldn't be memorizing because nobody decided to scrutinize or challenge
or ask the obvious questions.
Right. And so this is where there's a danger in memorizing. Sometimes you got to do the test again to find out if they covered every base, if they really came to their senses.
It goes back to what we were talking about when we were talking about old people and young people, where it's that traditional sifting, where you have traditions that are passed down. It could also be knowledge. I'm just going to call it all traditions. Things that generations pass on to the next generation, I'm just going to call it tradition. And with traditions is they get passed down in the past word of mouth, obviously, because we didn't have any internet or anything.
Yeah.
But it's up to the new generation or one person in the new generation to kind of capture a flaw in the tradition.
Yeah,
like
cast
sift
doubt
it.
on it.
Like something, like someone has to pick up, like, oh, something's wrong here.
Yeah.
Like most of the tradition, like obviously they're not going to pick up on all
the emperor
all the
has
flaws.
no clothes. The kid says it in the
there's,
cloud.
There's some. Yeah, it's not an old man. It's always some.
It's
some,
the naive
some young
kid
who
the naive kid who says, you know, I'm not biased by anything.
Yeah.
Hey, the emperor has no
It's
clothes, and everybody says, "Shut up, kid."
But that's kind of the job of the younger generations to kind of overthrow the decrepit parts of tradition, because there's obviously most traditions that have lived this long are useful. You'd think, right? But there's a few, such as the ones that we harp on so much, which would be physics. That one's corrupt, like just up and down.
But again,
right,
how do you know that it's corrupt? In other, how do you get that word across to people that there's something wrong?
Again, you have to kind of delve deep. That's why it's a problem, because it's not just a superficial. You can't just come and say, "Look, black holes are irrational." It's like, oh yeah, but I don't know enough to challenge it.
Yeah, that's
so it's like,
part of the problem.
It's like
it's a serious problem.
It goes back to that many people can't be wrong, and what do I know? That's what it comes down to. That's what it comes down to.
Yeah,
it's very simple. But you could say that about chemistry too. I can't walk up to, or at least I don't think I could walk up to a chemist and say, "Hey, look, I think there's a problem with, I don't know, salt. The way you guys."
Well, you would have to study salt on your own and do an investigation, and then compare it against the mainstream, and then say, "Oh, there's a problem here," or at least there's something I don't understand, and you either get a solution to what you don't understand, or you challenge the mainstream and say, "Look, you guys are wrong here."
But it's both. It's when you have a question that goes unanswered, or it gets answered, but you're not satisfied with the answer. It just keeps coming up and coming up. It's like, why can no one answer this in a way that satisfies me? Like, am I wrong about something, or is the establishment wrong,
or is there something I don't understand?
So it could be many things, but I think that's how it works. You know, when someone has an inquisitive mind and there's a question that just keeps not getting solved,
answered, or
I mean, I think that's what most theologians are about, because
all
there's
dissidents
some question about God that keeps like poking you in the back.
Yeah,
and it's like they're just not getting that answer. So it just kind of eats at them, but most people kind of just let it go.
And it happens with all these dissidents. Not all of them are right, of course not. I mean, they have their own theories, and a lot of them have to do with misunderstanding of, first, of the mainstream, and second, of foundations of physics. And so they have all these different ideas, and that's fine. You know, everybody believes in whatever they want to believe. But again, it doesn't mean that because you're a dissident that we should pay attention to you.
Flat earthers.
Yeah. I mean, I have no problem listening to these people, but it doesn't mean that you're going to accept their excuse or their version of how things work, because theirs are more irrational than the mainstream sometimes.
But my point with flat earthers is they have some questions that we all kind of take for granted, right? They have
which is good, because sometimes they point because they point to
the flaws in the mainstream,
right,
the mainstream narrative,
and so that no problem there. I have no problem, like the electric universe. They have a lot of people who have good arguments against what exists, mathematical physics, quantum mechanics, especially general relativity. And so in that sense, it's very good to listen to their version of their criticism of mainstream. That's where it stops. You know, you don't want to go into into what they're proposing because it's more irrational still.
No, but you do want to listen to it.
No, you want to listen to it. What I'm saying is, it doesn't mean that because they have a good argument against the mainstream, that because of that they have a good alternative. Yeah. That's where the reasoning fails. It doesn't follow. It doesn't follow that because they have good criticism, that they have figured out how it really works, because what they are proposing is more irrational still.
But I like the phenomenon of flat earthers, because I mean, many people just kind of throw them by the wayside, like, oh, these people are so dumb, like, come on, we figured this one out already, can we move on? But that sort of mentality is kind of what keeps traditions alive and kills and prevents the weeding out of corruption. When you say, oh, we already answered that question, we don't need to rediscover that, because like, oh, we got that. You know, gravity is this, magnetism is that. Just put it under the carpet. You know, the world is a ball. We're done.
No, but you know, one of the good things about things like flat earthers is that, you know, I mean, you know, I can't accept what they're proposing, but what I like is that, you know, they make you think in a different way, because they came out of nowhere and they say, look, well, what about this? You know, and what about that? And you say, okay, yeah, I see where you're coming from, but it's an angle that you won't find in the mainstream, because the mainstream probably would have never come up with that angle. Whether it's rational or not is irrelevant. The point is, they come and make you think from a different angle, and that focus is just interesting, and it's nice to say, okay, I see how this guy is thinking now. You know, it just gives you a different focus on the problem, and that I think that alone has value, just that alone. Yeah.
What about the ridicule? Because I think what gets flat earthers so much
riled up.
Yeah, what gets them riled up is that no one takes them seriously.
Right.
And you know, obviously everyone's like, oh yeah, come on, we figure this one out, but that what do you have to say about the offhand ridicule? Because you get it all the time. Where you present something, and no one takes you seriously just for science sake. They just kind of offhand say, "That's dumb." On to the next thing.
Yeah, and again,
what do you have to say
the
about
reason I also ridicule the establishment is because that is the circus we have out there in science. I didn't create that circus. That circus was there before I was born. And when you go into so-called science, into physics, you know, they laugh at different ideas that are not mainstream. And this is a problem because, you know, we should let everybody just present their case. And if you can laugh at them if you want, but let them present the case. But if you're not going to let them present their case and laugh at them, we have a problem there, because now you're censoring that person. And maybe that person deserves to be laughed at, but not censored. Don't censor them. Laugh at them, yeah, fine. You know, say, you know, what you're proposing is ridiculous. But, you know, we can say that about the mainstream as well. I mean, black holes, Big Bang, creationism, dark matter, particles of mass. I mean, that is ridiculous. All of that is ridiculous. And so, you know, but you're not allowed to ridicule them, but they are allowed to censor and ridicule you. And so that's we don't have a level playing field.
I don't know who said it. It was like Oscar Wilde or someone who said that the doubt is the best thing for that sort of thing, where the people who are the most sure of themselves are the dumbest.
Yeah.
And the people who are the smartest are full of doubt.
And part of that has to do with the fact that we memorize in school. We just memorize, and then we become dumb because we say, well, you know, it's already been proven. And we don't even question it. And that's a big danger there. Anyways.
Bertrand Russell.
Bertrand, okay. Anyways, you know, I did define the word irrational. And I have 4 criteria for that. And they're the conversion of concepts into objects, using undefined words or using them inconsistently. Then the theory doesn't follow from the assumptions. And the last one that I have included recently is to describe and claim that you are explaining. Okay? And that fourth one, you know, that's quite popular in mathematical physics today. They claim that they can explain, for example, how a magnet works. They say how a magnet works, and they have not explained it. They just described that positive attracts negative, north attracts south, and south rejects south. That's all they're telling you. And the same thing, you know, when they say, you know, the moon doesn't drift out of the solar system because there's a gravity well, a depression in space-time. But what are they using? They're using the concept field or the concept gravity well or the concept space-time, and that's not an explanation. Again, you know, when you take a concept and you use it as a physical object, what you're doing is really doing it in reverse. You're not explaining. What you're doing really is describing using this concept and twisting it around, say, oh, I have explained. So all I'm saying is that fourth one has been added. I've added that recently, and I'm saying, you know, to describe something and claim that you have explained it shows first, you don't know the difference between a description and an explanation, and second, that it is not an explanation. You know, you haven't explained how the magician did the trick. All you did was, you know, describe what happened on stage.
Well, how something works could have two interpretations. I think the question is vague, because when someone says, how does a remote control work?
Yeah,
you
but
press
see,
the buttons.
Yeah, but all
But
these,
that could also mean, how does a remote control work? Like, what are the intricacies, the electric components that make it work?
yeah, and this is where the problem, and that's why they confuse description with explanation.
How does
because,
gravity work? Drop something.
Right, right. And so this is the problem. People think that they have explained or that they understood the mechanism, but they're not dealing with mechanism. They're just dealing with a description. You know, to say, how does gravity work? And you say, well, the pen falls at 9.8 meters per second squared. Well, you haven't explained anything. All you did was, you know, describe it mathematically, you know, the speed at which the pen falls to the floor. It doesn't, you haven't explained the mechanism, why it goes down to the floor instead of the ceiling. And so, you know, we have to separate these things, and that's not clear. When you go through, like if you go through YouTube, you'll find a lot of people saying how magnets work. And what they none of them do is explain how magnets work. In other words, yeah, how in the sense north attracts south, that's not a how in the sense of an explanation. That's just a description. And if you can't distinguish between the explanation and description, then I'm saying, then, you know, you've got an irrational explanation, because you substituted explanation, description for an explanation. And so, okay, so those are the criteria for irrationality. So there is an objective criteria that I'm proposing, and those people who don't like it, it's because, you know, I'm touching their religion. Fine, no problem. You don't like it, you tell me what you mean by rational. Give me an objective definition of rational or irrational. And that's where they all run away. They say, well, you know, I don't deal with that. But see, they want to consider themselves rational without defining the term rational, and that's unacceptable in science. That's okay in ordinary speech, but not in science. You mean
consider their theory rational?
Yeah, and again, I made a point also in the article there on Quora that, and my son beat me up so much on that I had to concede. It's not that you're treating the person as irrational. That might follow. You might conclude that indirectly or extrapolating or whatever. But the point is that when you use the word irrational or rational in a scientific way, you're not referring to the person. You're referring to the theory. You're saying, look, objectively, is this theory rational? And then you go through all these criteria and say, no, it fails this criteria. You're using a concept as an object. You haven't defined this term, or you used it inconsistently. Your theory doesn't follow from the hypothesis. Your explanation doesn't follow from your assumptions, that sort of thing. And you do it objectively, and you say that the theory is irrational, or rational for that matter, and not the person. But, you know, it's like everybody takes it personally and saying, oh, he's criticizing me. No, I'm criticizing your theory. Okay? So the word irrational, rational should be applied to theories. Anyways, I have defined also the word knowledge, and my son still has an action item. He will deliver it, I think, at the end of the year.
Yeah, sorry, I have an actual job, ladies and gentlemen.
So it says knowledge.
I got a day job. I don't have time for this.
Knowledge, the ability to predict the outcome of an experiment without error. That's my definition of knowledge. And again,
but what if it happens to have no error? Did you know then?
Yeah, but see, the point is that we don't know that before you run the experiment. That's the point.
Yeah, but if you run the experiment, you knew.
And if you run the experiment and it comes out wrong, you were guessing.
Then then you don't know. But
then you can't say in retrospect that I knew.
But you said the definition is running the ability to predict the.
It's there. You can just read it there.
The ability to predict an outcome
of an experiment without error. Yeah.
Without error, that just means you just have to do it once. I predict that this pen will fall to the floor. You drop it. It happens to hit the floor. I knew. Forget any next experiments, but at that time I knew.
You guessed.
But
I'm saying you guessed.
You said that was knowledge.
Well, no.
I did it without error.
Well, hold it. I can say you guessed, okay? And you say, well, why? Because I'm saying, well, you did not know. You were betting. You placed your bet. Did you really know? Did you? I mean, I can guess too. Many things, and it just turns out that I guessed right for this specific experiment. Did I know or did I guess?
Going off.
How can you distinguish those two?
I don't know, but going off of this definition,
oh, you don't know?
Going off of this definition, I knew.
No.
By your definition, I knew.
No. Because I'm saying that because again, and I'm saying that you can't distinguish knowledge from guess. And if you guessed, assuming, right, that you guessed something, like I've got a coin.
Let's throw a die. If you throw a die,
right,
and I'm gonna say it's gonna come up 5, and it happens to come up 5,
right? Did you know, or did you just guess? I mean, we all can guess.
According to your definition, I knew. Because I predicted the outcome and it was without error. Yeah,
but see, the issue is that if you did not get it, then you guessed.
But if I do,
but you can't distinguish between guess and knowledge.
That has nothing to do with your definition.
It does.
The definition is missing a few words.
No, the issue is that you can't distinguish between knowledge and guess.
That's besides the issue.
No, it's not. It's not, because I'm saying that all knowledge is guess. All of it.
That's also besides the issue.
Yeah, I mean, we can replace the word knowledge with guess, and you would not be able to change that.
Yeah, because with guess,
it
could be with error.
Yeah, but
guess would just be
and tell me what the difference is.
Because one is with error or without error, and the other one is without error. One is either or. You could say anything. And knowledge is you do the test and it just happens to be right according to your definition, so you knew.
But the issue is we don't know in advance.
Clearly speaking, if you were right, we don't know if you knew or guessed. If you were wrong, you guessed.
Yeah, but then you didn't know.
That's what I just said.
No, but my point, you don't understand still. You still don't understand the definition. In advance, you cannot know, because we don't even have to run the test. It's not a question of saying, let's run the test and see if I knew. No, we don't even get to run the test, because you will not be able to predict without error. Predict. Not do the experiment, but predict it.
But you can predict.
No, you can't. That's the point. We don't get to run the test ever.
Yeah.
We never get to the point.
I have the ability.
No. Because because we're talking about prediction, not about running experiment.
Nowhere
does it say run the experiment.
You don't have to run the experiment. I'm saying
you
cannot I have a mouth.
Yeah.
And I can give a
prove
prediction.
to me that you can predict the outcome of an experiment without error. Show me before we run any experiment that you will. No, you tell me.
No,
you
give me an experiment. And I'll give you a prediction.
No, you can't give me a prediction.
Well,
not one. Just no, you can't. Okay, dropping a pen. Letting go of a pen. What will happen? Tell me without error.
Yeah, without error.
Yeah.
The pen will go up. That was a prediction.
The pen will go up.
Yeah, that was a prediction.
And?
All you're saying is the ability
and
to
you
predict
without
an
error.
outcome
Are you sure that?
without error.
Yeah, without error. And you're saying, why will it go up? I mean, without running an experiment,
Yeah.
tell me why it will go up.
It doesn't say why. I didn't say I have to explain myself.
No,
I just had to
but I'm
predict.
saying you can't predict because I'm saying
I
you're
thought
wrong.
We just had to predict, not be right.
No, but without error is right.
But then you have to run the experiment.
No, you don't.
No.
That's the point. The point is you never get to run the experiment because you cannot guarantee to me. You cannot guarantee to me that something is.
But then all we're saying is I can know something, but you can't know if I know. You can't be sure that I know.
Right, and
But
knowledge is what you prove to someone else.
That's not what it says here.
Yeah, without but
I can just predict it to myself. I can be the only guy in the room.
you could be your own audience, no problem.
I can be the only guy in the room.
Right, yeah, and you prove to yourself.
No, I don't prove.
No, that's what knowledge is.
And
without error. Well, it's without error. How
no
can you
word
guarantee to yourself that you're going to do it without error? Please show me.
There's no guarantee in here.
Yeah, it is. It says without error. It says it's got to be without error. Now show me.
But you don't have to. This is my point. You don't have to be sure that it's gonna be without error.
Yes, you do, because it says the ability to predict without error.
Whether someone knows it's without error or not is besides the point.
Huh?
Whether someone knows that it is without error is besides the point. That's not in here.
I don't know what you're saying. Okay, and what's your argument?
That is my argument. Whether someone knows that it's actually true, that it's without error.
That's the definition of knowledge.
No.
What do you mean with knowledge?
Without error.
Yeah.
There's no one who can say that it is without error or not. Right?
You cannot guarantee.
Whatever
prediction you make.
You don't need a guarantee.
Yes, you do. It says without error.
Yeah, but no one has to know that it's without error. That's my point.
You have to know.
No, you don't.
To yourself.
No, why?
Because it says without error.
Yeah, but let's say for the sake of argument, back to the sake of argument, that I say that if I drop a pen, it's going to go up, right?
Okay.
And that not that we're going to do it.
Can you guarantee it?
No. Hold on.
Yeah.
And Mother Nature, some ghost that the way we use Mother Nature, the one who actually knows, right?
Air pulls it up.
No.
Yeah, okay.
Mother Nature is the person who actually knows, right? What's gonna happen for sure?
No, wrong.
What?
Wrong.
That's my assumption. Hello, you can't be wrong about an assumption.
No. Even Mother Nature, not even God knows what's going to happen in the future. That's the point.
Not even theoretically.
Not even theoretically. That's what the definition is all about. It's saying you don't even have to run the test. Not even Mother Nature knows what's going to happen next. Why would she know?
Theoretically speaking,
something's
going to happen.
Yeah.
And theoretically speaking, if we had a ghost that knew
why would
exactly what's going to happen.
Why would it?
That's
why
irrelevant.
Would?
Why they?
No. Why would Mother Nature know?
That's irrelevant.
No, but
that's irrelevant to my point.
Huh?
That's irrelevant to my point.
Okay, what's your point?
I just need to establish a referee that knows what's going to actually happen, regardless of what I.
Why would that referee know?
No.
But what do you mean a referee? Who's the referee? Mother Nature, God?
Yeah.
How would they know?
That's irrelevant.
No, it is relevant. I want to know how they. Why are you selecting them as a referee?
I'm getting to that.
Oh, okay. Go ahead. Please
so
don't let me.
We have God, right?
Yeah. We have God. Yeah, God.
He can't tell me what's going to happen, right? There's no communication. He's just somewhere. So let's say he's the referee that knows exactly what's going to happen without error.
No. Hold it. Hold it. That part. Part you got to clarify.
Okay, why?
Why would he be a referee? Why would he know?
That's irrelevant.
No. If you're going to select him as a referee, it is relevant.
Why is it relevant?
Because I'm saying not even God or Mother Nature, nobody knows what's going to happen next.
But I'm saying
anywhere in the universe.
You're saying it's irrational.
Even theoretically.
But you're saying it's irrational to even ponder the question that someone can know the future.
Right.
Not a human being. I'm talking about a supernatural being.
Anybody.
Why is that? Why can't you even
the block universe? The block universe. The future has already happened.
Yeah. For example. Yeah.
Well, that's the point. The point is that
this
the point is that if it's already happened, it's the past. It's not the future anymore.
But if you can't even postulate a supernatural being.
No, because then you have to postulate, and you don't even have to postulate a supernatural being. All you have to do is postulate the black universe, and we're done.
Which is supernatural.
Yeah, you could say yeah.
Okay, so can we start there? Now
no,
can I continue?
No, because then we have a contradiction right there and then that the black universe means it's already happened. The future is the past. So we're not talking about the future. I'm talking about predicting the future, not about the past. Anybody can predict the past.
Well, when you're talking about
the only way God can predict the future is if it's already happened.
When you're talking literally, there's no such thing as the future. So the
right.
whole point is moot anyway.
Right.
There's no such thing
and
as
that's my point. That's the point of the word knowledge. That the future has not happened. So the only way you would know is if it's the black universe. Hold it. Let me finish. The only way you would know exactly, without error, that the pen is going to fall to the floor or whatever, is if it's already the past. And you're just essentially regurgitating what's already happened, the black universe.
But the whole point is moot if you can't even talk about prediction because there's no future.
Correct. But that's my point with the word knowledge.
Point.
It's more or less the same argument as saying that you know that Napoleon went to Waterloo. You don't know because you can't reproduce the experiment. So what you're talking about is really explaining, or describing, but not about knowing. This is something similar, but applied to the future. You can't know the future. You can't predict the future because to predict it without error means it's already happened. Only then can you do it. But then you have a contradiction in that it's the past that that you know for sure it happened.
What about assuming the future?
That's different. Assuming is different than knowing.
But is that what people mean? Because they go assuming. I mean, there's a whole bunch of unspoken assumptions anytime we're talking, right?
Yeah.
But when I say the dominoes are going to hit each other and the fourth domino is going to fall over, for example, that's a prediction. And it's really more of an assumption, assuming, nothing weird happes.
Correct. You make a set of assumptions.
But you don't say them out loud. That's the tricky part. When you're predicting,
they're implied.
There's a lot of implied. It goes back to the what do you call it? The shooting the racehorse analogy, where the assumption, the implicit assumptions are assuming nothing weird happens.
Right.
La 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 la.
Yeah, and that's why I'm saying you can't predict unless you know all the. In fact, you had what was his name? French guy who said if he knew all these variables out there. Everything that if he knew the movement of every single atom in the universe, then he could predict the future. He could do that. Lagrange, was it? Yeah, I think it was Lagrange. Anyways, he said he can predict if he knew if he knew everything that was going on. Like for example, Mother Nature would know everything that's going on, every atom, how it's moving, everything you're thinking. So if she has all that information, then you can't fool her. She knows exactly what's going to happen next.
Why'd you shit on my supernatural being? Why is that one allowed?
No. All I'm saying is this is what I think it was Lagrange was saying. He was saying, if I knew all these variables and knew everything you're thinking and everything that everybody's thinking, I had full knowledge of all the variables and all the movement of every atom in the universe and all the thoughts that are being created, then I could predict the next, what's going to happen without error, without,
I would say that's true if you're not part of that universe. If you yourself are not connected to the ropes.
God?
No,
He's outside the universe?
No, but it's true because if you're part of it, then you can change. I guess that's a conversation for a different, but you know what I mean. Like if you're part of it, then okay, now you're literally moving your arm, so you're changing it. But then you're gonna move your arm. So I guess that's it goes back to the question: can God see what He's gonna do next?
Right.
But that's why if you take yourself out of assuming all the atoms are connected by ropes and everything, if you have this cluster of rope or thread, that we'll call that the universe.
Okay.
And you're outside of it. Assuming you could see it or whatever, I guess you don't even have to see it, but assuming you knew everything that's going on in that cluster, then yeah, I think you could predict everything.
Except that we have a variable, which is what people think.
Yeah, you can see that too.
You can't really do that.
I would argue.
Well, you know, that's a little more difficult to, and that is for a long argument. The fact that, you know, if God knows exactly what you're thinking, maybe he can predict everything, right? But he would have to know not only the mechanical stuff, how matter is moving and how fast and all that, how much things weigh, but on top of that, he knows what you're thinking, and that you might change course and say, oh, instead of going left, I'm going to go right. But just imagine that for a second. God knows exactly what he's going to do next. He knows the future, right? Well, that's kind of weird, because imagine God knowing exactly what he's going to do next, and then he knows exactly what he's going to do next, and what he's going to do next, and what he's going to do next.
Not what I was talking about.
No, but just let me follow this train of thought. And I'm saying that if God knows what he's going to do next, and he knows he can't avoid it, you know, he's got no free will.
But that's what I already talked about that earlier.
Yeah.
Assuming God is outside of the universe, outside of that cluster,
No, about him
outside
himself.
of the things that he knows, basically.
No, but I mean, talking about himself. He's alone in the universe.
That's what I was talking about. If God knows what he's going to do next, then it gets weird.
Yeah, it does. I mean,
quick, but that's what I'm saying.
It's like saying I can't avoid it because I know
but that's
what
why
I was
I was
going
talking about the Lagrange thing, whereas
or Laplace. It could have been Laplace. Yeah,
it would
one
make
of those
sense if you're not part of the universe that you know of, because then it gets weird.
Yeah.
You'd have to be outside of the universe cluster.
And then again, why would you know what the guy is thinking?
Well, that's different. We're talking supernaturally.
Right, yeah, and you're talking more on supernatural. You're talking something impossible, unimaginable.
I don't think your brain can hold that many variables at once, obviously.
And so, you know, again, I reject the word knowledge from science. I don't think there is such a thing as knowledge. Anyways, science deals with explanation, doesn't deal with knowledge anyway, so in a way it's a mood issue.
But it deals with assumptions, which is the next best thing.
Okay, I like that. Yeah, it does deal with assumptions, but primarily, you know, where
we got.
Yeah, but remember, science vibrates in explanations, in theory. That's where it really vibrates. But the assumptions are important. Obviously, you need assumptions before you can go into science, especially in physics, right? Anyways, we're going to continue this tomorrow. We got a couple. I can't seem to get to quantum, even
no one
though
wants to get to quantum. I'm trying to stop.
I want to show that, you know, quantum is irrational. I've been trying to show this for the last 3 days, but I can't seem to get there. But hopefully we'll get
to change the title of this.
Yeah, I changed the one for yesterday. You know, from definitions to objective versus subjective. And today I wanted to put irrationality for quantum, but I got to change this one as well. I'll do that tomorrow if my son lets me. And otherwise, I'll have to overrule them, beat them up, you know, hit them with my baseball bat.
I'm here to derail tracks, derail trains.
We'll see you tomorrow, and thank God, you know, the technology worked. We'll see you tomorrow. Same time, same station. See you then. Bye-bye.